Hello everyone, welcome to this session. So in this session, we will use the iris flower example to show the implementation of the MATLAB built-in function of SVM classification. So let's first see the hard margin one. Now let's first load the data, load the feature iris. I think you have seen it for quite a few times, right? So these are the measurements and of 4 features, and these are the labels. So then to make it linearly separable, we extract the first 2 features and the 2 species, right? So now I'm using the first 80 samples as the training data and the subsequent 20 samples as a test data. So now I prepare the training set and test set. Then I need to train an SVM, the hard margin classifier. So my question is that what kernel function and what the box constraint value should I use when I consider this one as a linear separable one and hard margin classifier? So the answer is here, right? So with the kernel function, we select linear, and the box constraint, we select infinity, right? So remind the box constraint. So this is a C value, right? So this value, we call it a box constraint, C. So as we have said before, C controls the trade-off between the margin violation and the margin themselves. So if we use a large C, this one we prefer a small margin violation, so more accurate classification, but the generality is smaller. So if we use a small box constraint, then the margins are large and more generality. So when the box constraint is infinity here, so this one becomes a hard margin classifier. After we train the classifier, we can use it to predict the test data, right? So we can see that using the predict function, the output SVM, this is the object, as in the last slides, and x underscore t, so we put the test data. Then it will give me the y-pred. After that, we can calculate the prediction accuracy. Let's first count the number of the correct classified samples using these commands. Then we can calculate the accuracy. So if you try this example, you will see there is a 100% accuracy in this example, right? And to broaden your scope, you can also plot and visualize the results. So in many cases, this is very useful to observe at what you obtained. So first, you can get the support vectors and classifier coefficients. These are the things, the basic things that we can generate the support vector and the boundaries, and we can draw them, right? So as we can see in the last session, we can get the support vectors, the beta and the bias using the dot notation, right? Then we can plot the data set. Data set is here, and the support vectors are plotted here. Then we can plot the equation of the linear classifier, W transpose multiply X plus B. We can see the functions here, right? And then we can find the equation of the margin boundaries. We can see the equations are here, the two lines, right? The boundaries. Then we can plot them. Then we can add the labels and legend. After all these steps, you can try yourself, and we see the result is like this. So these are the 2 class of data, and we see the support vectors, the hyperplane, and the 2 margin boundaries. So from this one, we can see that the margin boundaries, the margin is very small, right? So this will harm its generalization ability. So we can use a soft margin classifier to allow some margin violation, right? So then we can see that we can control the box constraint, right? So here I set the value to 1, and you can see this is a command that I'm using. So box constraint equals to 1. So note that for soft margin classifier is not only applicable to the cases that is not linear separable, but nearly linear separable. So even if it's linear separable, if you want to improve the generality, you can still use soft margin, right? So for example, in this case, I put the box constraint to 1. So this value, you can try different values and compare the result and select one that shows the best trade-off. So in these slides, I tried 4 values. The smallest is 0.0625 and the largest is 100. We can clearly see the trade-off that we have discussed before. And we can select the one that we like, that is more in line with our intention. So all of these are in the live script, and you can try yourself. Okay, so that's all for this session. Thank you very much.